Hello, we are going to talk about factoring today. We started factoring with the greatest common factor, and now we're going to be factoring our binomials. And so to begin with, it's kind of just a backwards operation. So when we're talking about addition, the opposite of that is subtraction, or the backwards operation is subtraction. Multiplication and division go together. Squaring a number and square rooting a number go together, and so multiplying a binomial and factoring a binomial go together in the same sort of way as these other three relationships. So you have these examples on your paper, and what I first want you to do is draw these lines to separate it like this into the four types of squares we have. So we have the x squared box, and then we have the box that has x's in it, and the box that has x's in it, and the box that has singles in it. The reason we're going to do this is this kind of makes it look like our four squares, which we're eventually going to be moving to. Now we kind of already did this the day that we did our tiles in class, because we talked about working backwards with the tiles. So this isn't completely brand new, but you might be starting to think about it a little bit differently because you're getting so much better at this. And so when we're factoring these, we know that in order to get an x squared, we have to multiply x times x. In order to get 5 x's here, we have to multiply this x times 5 singles. And then to multiply, where am I? To get this x, we'd have to do 1x times 1 single. And so filling in these things, we end up with x plus 5 at the top and x plus 1 on the side. So a couple things I want you to start to notice is that this number times this number gives you this one. And when you combine this number and this number, it gives you this one. So when you multiply your two numbers together, you get the last number, and when you add your two numbers together, you get the middle number. So that's something to kind of start keeping in mind. Over here, we're going to start with splitting it up. And so to get x squared, x times x. And then we have this x, and we have 5 red ones, which means we had to multiply by negative 5. And then over here, we'd have 2 red ones, we had to multiply by negative 2. And then these negative 2 times these negative 5 would give me the positive 10. So we have x minus 5 and x minus 2. And if I look at this, negative 5 times negative 2 would give me positive 10. Negative 5 combined with negative 2 would give me negative 7. So we multiply, we get the last number. We combine, we get the middle number. We're going to work with the tiles for a couple more, and then I'm going to take the tiles away. So for this, we would need 2 x bars over here and 1 x bar at the top. And then to get all of this over here, we'd be multiplying these 2 x's by positive 4. And then down here at the bottom, this x times a positive x. So x plus 4 and 2x plus 1. lines. That's really bad. I'm going to leave it though. I'm not going to erase it. Don't judge me. Let's see. X and X. And then before we even do this, if I think about what multiplies to get to 10, I can multiply 1 times 10, or I can multiply 2 times 5. So my factors are 1, 2, 5, and 10. And then thinking about which of those two factors add up to 7. 1 and 10 don't add up to 7, but 2 and 5 do add up to 7. So I would need an X plus 2 and an X plus 5, which works out great that I have an X plus 2 and an X plus 5. Okay, so the tiles make this process so much easier. However, when we leave our tiles and we have to factor it with just our box method, we have to think a little bit more. So we set up our box, and right now we know that x squared has to go here and 8 has to go here. So I'm going to go back to one of our boxes. So you see how this box only has x squareds in it, and this box only has singles? Even if I go back here, this has x squares and this has singles. This has x squares and this has singles. This has x squares and this has singles. But the opposite two boxes, they have a combination of the x bars. And so if we just look at the middle number, we don't know how many x bars go in which box. So for example, here I know there has to be 7 x bars, but I don't know if there's 5 and 2, or 3 and 4, or 6 and 1. That doesn't make sense. I guess it could. So I don't know what the combination is, which is why we have to leave them blank. So I know that I need a total of 6 x bars, but it could even be that there's negative 8 bars in one box, and there's positive 14 bars in the other box, and that's how I get to 6. So that's why I have to leave them blank, because we don't know what the combination is right now. But we start with what we do know, which is that I have an x squared here and I have an 8 here. So then you think about the factors of x squared. Well, there's only one choice. This has to be an x, and this has to be an x. So it's kind of like a puzzle. So those are my factors of x squared, has to be x's. Then think of my factors of 8. Well, I can multiply 1 times 8 or 2 times 4, and that's it. That's what we did our practice with factors in class. So which of those add up to 6? So of my factors of 8, which of them would add up to 6? Well, 2 and 4. So I can put a 2 here and a 4 here. This is why a pencil is very important in math class. So I can do x times 4, so I'd have a 4x here. 2 times x, I'd have a 2x here. And then we always have to check, does this add up to my middle number? And it does. So my factors would be x plus 4 and x plus 2. Okay, let's try another one. So I have x squared minus 8x minus 20. So I can start with the x squared goes here, the negative 20 goes here. Start with my factors of x squared, which is x and x. And now I have to think of my factors of negative 20. I can do negative 1 and 20, negative 2 and 10, negative 4 and 5, or flip my negatives to the other one. So those are all of my factors. Those are all of my choices, my combinations of what I could do. So you think about which of these combinations would give me a final product of negative 8. I'm sorry, a final sum of negative 8. You might already know what it is, but I want to try something that I know that it isn't, just so you can see how this works. So if I'm not sure, I can just pick something and I can just guess, and I can say, well, let me try -4 and 5. So I put a -4 here and I put a 5 here. These two multiplied together give me -20. So now I fill in my other boxes. This would be 5x and this would be -4x. Now when I combine those two, I end up with positive x, which is not what this says. So that means I'm not right. So I erase it and I try something else. So I think, okay, maybe it's 2 and -10. 2, -10. This gives me -10x. This gives me 2x. I combine these two, I get -8. So that must be what it is. So sometimes you're just going to have to try something and hope for the best. See what happens. The next one. So for this one, we need to first think if there's a greatest common factor, which there is. All of these are divisible by 3. So if I take out the 3, then I'm left with x squared plus 7x plus 6. And this makes things so much easier. I could still factor this out with the 3 in there and get 2 parentheses, but I'm going to have a lot more factors to consider and it's going to take a lot more guesswork. So if there's a greatest common factor, it's easiest to take it out first. So I take out the 3, I'm left with x squared plus 7x plus 6. So now I write x squared and I write 6. My factors of x squared are x and x. It's my only choice. The factors of 6, I could do 1 and 6, or I could do 2 and 3. So which of these combined would give me 7? I hope you said 1 and 6. So this gives 6x, this is 1x. These combined give me 7x. So I have x plus 1, x plus 6, and 3. So I have 3 factors for this. Now, because we know how to distribute, something that would be equivalent to this would be 3x plus 3 times x plus 6. That would be equivalent. I just distribute it to the first set. I could distribute it to the second set and say x plus 1 times 3x plus 18. And that would be also equivalent. So if you didn't factor out the 3 from the beginning, you would have gotten one of these two as your factors on the side. So we have one more. We can start with 2x squared and 3. So for 2x squared, one of these has to be 2x and the other has to be x. And then to get to 3, I only have one choice. So maybe it's 3 and then 1. So I'm going to try that. If I do 3 and then 1, then I have 6x here, and I have x here, and that equals 7x. Well, that's not right. So maybe I need to switch them. Maybe it's a 1 here and a 3 here. So if I do that, I have 3x and I have 2x. Well, that doesn't equal 7, so that's not right. So maybe I need to switch them back and put a negative. If I do 3 and 1, that would still give me a positive 3. This would be a negative 6x, and this would be a negative x. And there we go. So sometimes it's kind of a puzzle that you have to work out. And then you need to decide which is the representation. Don't forget about your feedback form.